In this module, I will discuss the transport of non-aqueous phase liquids in the subsurface. In a previous module, I showed you this picture of the Sunflower Army Ammunition Plant in Johnson County, Kansas. At this site, there were several different locations of contamination that had occurred in previous years. If we consider the possible movement of that contamination, the properties of the contaminant are very critical to how that contamination is transported. So I previously showed you this picture in a module of a light, non-aqueous phase liquid into the subsurface. And here we have the source of this liquid, an underground storage container. And this would be a typical scenario for light petroleum hydrocarbons, such as gasoline. So the light non-aqueous phase liquid refers to liquids that are less dense than water. When a leak happens in an underground storage tank, the liquid is going to be transported into the subsurface according to the force of gravity. The rate at which this moves is totally dependent on the hydraulic conductivity K of the subsurface, which is a function of the geologic properties, and also the presence of water, or bulk fluid that moves the hydrocarbon. In this scenario, you'll see a concentrated plume, denoted by the red, and around that plume, you'll have a lesser concentration that's being caused by dispersion and dilution. As that light, non-aqueous phase liquid moves down, it will eventually hit the water table, at which point, because it is not miscible with water and because it's less dense, it will pool on the surface of the water table and be moved with the hydraulic conductivity of that water table. Now, because every compound has some small solubility with water, even though it's not completely miscible, you will have a lesser concentrated plume that enters the water table caused by dispersion and dilution. The concentration of this will be very small, and yet a small concentration, as you'll remember from risk assessment, can still be rather toxic or hazardous and create an immense amount of risk. But the main contaminant plume will pool on top. This very concentrated plume can act as a long-term source of pollution in the aquifer. The main water table will be moving away from the pool of concentrated pollution, and as it moves away, continued dispersion into the water table occurs. And so that's what I mean by a long-term source of pollution. Now the insert here is trying to show you what is happening at a microscale. So at a microscale, you have soil particles, water, and trapped air that might be present. And then you have your sorbed contaminant, or your NAPL liquid. And what this is trying to show you is that at a microscale, there is entrapment of liquid between the pores. And this will be significant as we think about remediating the site. If we draw out the contaminant, if we pump it out, for instance, there will always be these small entrapped particles or entrapped areas of NAPL, and these are very hard to completely remediate or remove. All right, so this is a picture of an NAPL, and the next picture is one of a dense non-aqueous phase liquid. So here you have a DNAPL, standing for dense. And this would be an instance of a chlorinated solvent, and we will learn about PCE in the course, which originates from dry cleaning or industrial activity. It's also the case of a crude oil barrel, where the liquid is very dense. So in this instance, when that contamination occurs, the plume here will sink, and when it interacts with the water table, you will have some of that dispersion and dilution and less concentrated plumes that move into the water table. But the main plume, the main concentrated plume, will continue to sink. And if it's a confined aquifer, meaning this barrier here is bedrock or perhaps a clay layer where you don't have good hydraulic conductivity, then that plume will sit on top of that confined aquifer layer. If there is an aquitude, or perhaps a region where the hydraulic conductivity is very high, the plume will continue to sink into the very deep subsurface. Now, from an environmental health perspective, this pooling here is very concerning because this acts as a long-term source of pollution for the aquifer. And so as this pool sits here, it will continue to disperse into the water table. And imagine that I have a drinking water well here, or an irrigation well here that's pumping out. This dispersion and dilution is going to reach my well and then create that human health risk for the population on top. All right, so I'm showing you two different pictures of an NAPL and a NAPL. The ultimate fate of the plume is dictated by the density of the fluid and the hydraulic conductivity of the subsurface. In the next module, I'll discuss some of the environmental engineering options that can be used to remediate these contaminant plumes.